Hi, how you all doing? So it's just a quick introduction to radians for you, okay? So radians is really crucial when it comes to trigonometry and when it comes to calculus, because you'll be using radians far more often than you realise, okay? Up to now you'll be using degrees, which is fine, okay? But when it comes to calculus, a lot of the A-level trigonometry questions, you will need to use radians. So how is a radian defined? Well, I've just drawn here a sector of a circle, okay? The O there marks the centre of the circle, okay? And a radian is defined such that if you draw a sector of a circle such that the radius is the same as the arc length, then the angle formed is 1 radian, okay? We traditionally use theta to represent an angle, of course, so I've labelled it as theta for the time being, okay? But I'll say again, the sector of a circle such that the radius is the same as the arc length gives you 1 radian in angle, okay? So what I'm going to do is I'm just going to rewrite that as 1 radian. Now traditionally the notation for radian is a C, or we just write rad, okay? I'm just going to write 1 rad for the time being, okay? Now just to simplify it a little bit for what I'm about to go on to, I'm going to instead give this a radius of 1, so of course that arc length is 1 as well, and you can do that using similar shapes, okay? You can call the radius 2, 3, R, anything you want, okay? I'm just going to call it 1 for the time being. Now, you know from the simple circular formula, circumference equals 2 pi r, that if this was a complete turn, a complete circle, then the circumference would be 2 pi, okay? 2 times pi, which is the radius, okay? So what that means is that the whole of this as a length, okay, for a complete circle would be 2 pi, okay? And since 2 pi represents 1 full turn, that gives us our conversion rate between degrees and radians, okay? That is 2 pi radians, okay, is the same as 360 degrees. Notice that we don't tend to use the units for radians, okay? So I've just left it off. So I've written it there just for a bit of clarity, but here it's quite common just to write 2 pi as 360 degrees, okay? And that gives us a rather handy conversion rate. So that means pi radians is just 180 degrees then. That is half a turn will be 180 degrees. And that's the conversion rate that you need to know. Now, even though you're allowed to use calculators for exams, I do strongly recommend that you try and learn some simple conversions between radians and degrees, okay? For that, it's helpful to know the fractional multiples of pi, okay? So I'm going to begin with quite a common one, that is pi over 6, okay? Now, whatever you do to the left-hand side, you also got to do to the right-hand side in the conversion equation formula, whatever you want to call it, okay? So if pi radians is 180 degrees, divide that by 6, divide that by 6, pi over 6 must be 30 degrees, okay? That's quite a common one. Another common one is pi over 4. So similar again, if you do pi divided by 4, obviously you get pi over 4. 180 divided by 4, you get 45 degrees. Okay. Another common one is pi over 3. Okay. So pi divided by 3 is pi over 3. 180 degrees divided by 3 is 60 degrees. Okay. And rather simple one, well I hope it's really simple. Okay. Pi over 2. So pi divided by 2, pi over 2, 180 degrees divided by 2 is 90 degrees, okay? And it's quite simple really. I mean, if you go back to the full turn being 360 degrees, half of that full turn will be 180 degrees, okay? A quarter of that full turn, a quarter of a full turn be 90 degrees, okay? Gives you that, okay? So quarter of full turn, pi over 2, 90 degrees. Pi over 4 then 45 degrees and so on. What I strongly recommend is that you just memorise those because they come up quite common. And when I say memorise them, I mean from left to right and right to left, okay? So as an example, if I were to just rub these off, you would need to know what each of these in degrees are in terms of radians, okay? So starting with this 2 pi is 360 degrees, obviously half of 360 is 180, half of 2 pi is just pi, okay? And then think about what fraction each of these are of 180 degrees. So 30 degrees, that's 1/6 of 180. Hence, it's 1/6 pi, pi over 6. 45 degrees, that's 1/4 of 180 degrees, okay? So pi over 4, a quarter pi. 60 degrees, that's 1/3 of 180 degrees, okay? so a third pi or pi over 3. And 90 degrees, of course, is 1/2 of 180 degrees, so half of pi or pi over 2. Okay, so that's just a brief introduction to radians, okay, and some conversions. Okay, if you want to know why we actually use radians, why radians are useful in the first place, then just take a look at another video I've done earlier on. Okay, and it's about a 10-minute video, and that explains to you about why we actually use radians in the first place. Okay, hope you found that useful.